function problems from the second worksheet have a couple that are, well, a few of them that you have to do a little manipulating before you can work on them. Number 2, okay, y is equal to the quantity of x plus 1 squared minus 2. You can't do this one the way it's set up. You've got to do the FOIL method first, or the lattice method, whatever you want to do with this problem here. So it's got to be x plus 1 times x plus 1. Now, when you do these more, multiplying binomials, the FOIL method, whatever, you're going to be able to look at this and just know that it's x squared plus 2x plus 1. Okay, you don't need to do the first because you know x times x is x squared. You don't need to do the last because you know 1 times 1 is 1. You just need to know that 1 times x and 1 times x is 1x plus 1x, and it makes 2x. The middle part of it's there. Now you've got this at the end of it. So y is equal to x squared plus 2x plus 1 minus 2. Now that you've gotten rid of the parentheses, you can combine like terms. And it should turn into y is equal to x squared plus 2x minus 1. All right. Now, this is taking on a little bit of a different turn. This is actually pretty cool. You can do the vertex, you can do the max and the min. Right off the bat, max and min, you automatically know that this one is going to open up because it's positive. So you know it's going to look like this. You know it's going to open up, so you know it's going to be a minimum. You don't even need to do any work with this one to know that. You just need to see that there's no negative sign in front of the x squared, so you know it's going to be opening up. But first things first, you've got to find the axis of symmetry. X is equal to negative b over 2 times whatever a is. Well, that's just 2. 2 times 1 is 2. Okay. Solve that. So x will equal negative 1. Yippity skippity. Substitute the negative 1 into this problem. Find out what your vertex is, and you're well on your way to doing this one. The biggest problem with this one is getting rid of the parentheses so that it is in a quadratic simple form or simplified form, so you can work on it from there. Now, finding the x-intercepts in this one, it doesn't ask you to do that, but I would say get in the habit. Get in the habit of finding the x-intercepts. It's good for you. It gives you a good idea of what the graph, if it's going to have 1 x-intercept, 2 x-intercepts, or no x-intercepts, depending on the problem. But it's a good problem to do. I like that. Alrighty, I just wanted to give you that little heads up. I'll come back with more stuff later and the work and things that we're going to be doing next week to finalize this year. So, yippity skippity.